So in this last prep guide, we read a piece of work by B.F. Skinner, and then we read Sam Harris, and I want to talk briefly about that and just give you sort of the view from 20,000 feet. I mean the big overview, not the specifics, because the specifics of the paper by Skinner, there's a lot of interesting things in there. There's a lot of stories. There's some figures. He tries to, draw this or draw that and describe what he's doing. And that's part of the big picture, is that this is a case history in scientific method. Now, case history is a method that we use in science, in the social sciences, in psychology especially, when we encounter something that we don't know much about. So if you encounter a person who has a disease or disorder or problem that doesn't match anything in the textbook, what you do is you do a case history. That means that or a case study, are synonymous terms for a way of, sort of documenting in great detail the issues and problems associated with this particular person. You might talk about where they were born and their background and their symptoms, and then you might talk about what you tried with them if you're a medical doctor or a psychologist or something like that. You usually do it over a long term study. You do it over a year or two or three or maybe even longer than that. And what you're doing is you're documenting this particular issue, and then other people will read it and maybe they encounter a similar issue, and then what we might see is we might be able to put these together and say, okay, there's an underlying condition that we recognize as disorder or disease X because all these people share it. And a lot of diagnoses come like that, a lot of rare things, in which there's only maybe a few hundred people in the world that have a particular disease. Someone has put together all these case studies and said, see all these similarities? We think this is an underlying disease that's specifically this or that, and then you can look for causes and so on. So that being said, when Skinner says, he calls this a case history, what he's saying is, one of the big points is, I don't know what I did. He's basically saying, I don't know what happened to me. I don't know how I was trained to be a scientist. I don't know what's going on. I'm just going to tell you my experiences, because most of my science training was in statistics and then in the lab. And so I think that's a really interesting point. B.F. Skinner, according to numerous polls, is called the most influential psychologist of the 20th century. This guy is not someone that we don't think is important. He was very important. In fact, he was, according to many polls and many surveys, the most important psychologist of the 20th century. And I would agree with that. I mean, but I'm a little biased in that respect. As a behavior analyst myself, he's more influential in psychology than Freud, than Jung, than Oliver Sacks, than Erikson, than Piaget, than all those names, because it's turned out that most of the principles, if not all of the ones that he specified, have held up under scrutiny. Freud, for example, in comparison, none of his principles have held up under scientific scrutiny. So this is a very influential scientist telling us that he's not sure how he was trained as a scientist, and the best he can do is tell us about his experiences. So one of the points that I wanted you to get out of this is to compare it with that first chapter in the textbook. And when you read the chapter in the textbook, in this side, they present this figure, the steps in the research process. You select a topic, you focus your question, and it's ordered 1, 2, 3, 4, 5, 6, 7, and your theory informs this, and you design something, and you collect, and so on. And this is how you do research. And then when you ask Skinner, what are the principles of the scientific method? He says things like, well, when you run into something interesting, drop everything else. Some ways of doing research are easier than others. Remember, he describes that story in which he He trains the rat to run back to the beginning of the maze, so he doesn't have to pick him up at the end and haul him all the way over to the start. Some people are lucky. Sometimes you just get lucky. Sometimes equipment breaks. Remember, he talked about he ran out of pellets, and hey, I didn't have to do what I thought I had to do. Serendipity was the other principle. That is finding something when you're looking for something else. So I think when we compare and contrast the steps of the research process as defined by a textbook and what the steps in a research process are from a real scientist, an influential scientist nonetheless, these are starkly different. We think of science as this great big thing, that it's well defined, its methods are clear and whatever, but scientists don't get a lot of training in science. What we do is we do science and learn as we go, and I think that's what Skinner is talking about. I think some of this difficulty rests on the meaning of the word theorem or theory. And I believe a theory is sort of like an if-then statement or conclusion or generalization about something. So a theory in cognitive or developmental psychology would be something like, if a child is abused, then they will abuse their children. And we know that this theory or this if-then statement, this particular one, plays out pretty. If you are abused as a child, you are more likely to abuse your children. We can say other things like, if a person with depression is given Prozac, then their depression will lessen. This is a sort of theory or theorem or hypothesis. If you're shown an emotionally provocative image, then your recollection of that image will be better than a neutral one. This is a theory or a hypothesis that a cognitive psychologist might study on the role of emotion in language learning. Skinner, was a little bit open-ended, or more open-ended. If I pull on a rat's tail, then what happens? If you don't reinforce every response, then what happens? So I think there are theories and hypotheses in Skinner's, but I think we can make a distinction between what we call confirmatory research and exploratory research, and that is X better than Y is a study in which you're trying to confirm something. Whereas if you're trying to determine the relationship between X and Y, that is more like exploratory research. I think another term that's thrown around a lot, and you may not encounter this, or you might, is the difference between deductive research. Do you let the research guide you to where you want to go, or have you deduced a set of issues that you want to draw conclusions about? And both of these have value. I'm not saying that one is better than the other, they're just different forms of conducting research. So I think all science begins with hypotheses and questions and assumptions and axioms. At its base, we assume that the world is an orderly place to a certain extent, that questions can be answered. And this brings us back to some of the original stuff that we were talking about falsifiability and so on. So I think we have to recognize, though, that what John Muir said was, when we try to pick out anything by itself, we find it hitched to everything else in the universe. Is that even scientists are dealing with problems of trying to isolate variables, but then they're not disconnected; they're connected to the rest of the world. Sam Harris, I think, gives us a great guideline for where we need to go, because we're still sort of caught right in this conundrum, or this contrast of, is Skinner right? Is the textbook right? What are we doing? What is science? Is science a method? Is it a process? Is it Is it a way of thinking? But I think Sam Harris nails it when he says, when you are adhering to the highest standards of logic and evidence, you are thinking scientifically. And when you're not, you're not. So I think the basis of science is logic and evidence. And if you're using logic, if you're using evidence, the best evidence that you have available, if you're pursuing evidence and new evidence and making sure that you have the best evidence, and you're logically relating it to the prior evidence that you have, then you're thinking scientifically. And if you're not doing those things, you're not thinking scientifically. So I think that's where we want to be, is we want to, the things that we want to consider in the social sciences and for the remainder of the course is, are we using evidence and are we using it logically? So hopefully that gave you a sense of what I wanted you